Well, okay. Everybody gather up. So, all right. We need to decide where to study rock joints. Did anyone come up with any ideas?
I was thinking about Seoraksan. The lock joints there are really famous and well preserved.
Seoraksan is a good choice, but isn't it too far? Traveling back and forth would take a whole day, and moving our equipment there would be tough.
Well, that's true, but the scenery is amazing, and it seems like an ideal place for data collection.
Let's put Seoraksan on hold for now. Then how about Bukhansan? It's closer, so it's easier to get to. And I've heard the lock joints there are also great.
Bukhansan is nice, but it's autumn now, and there will be too many hikers. If it's too crowded, it might be hard to focus on our research.
Well, then what about Gwanaksan? It's relatively less crowded, and I've been heard that there are some well-known spots for studying rock joints.
Naksan is great option, but I read that many of its rock surfaces are heavily weathered. It might be hard to find the sharp and clear joints we need.
And what about Inwangsan? It has plenty of exposed rock surface with clear joints, and it's really accessible from the city.
Oh, in Hangsan, well, I remember that there are some famous spots for studying joints there.
That's true. It's also convenient for transporting our equipment and seems perfect for collecting the data we need.
So should we settle on Inangsan?
Well, sounds good. Well, I'll organize a schedule and make a list of equipment we'll need it.
Perfect. Let's all prepare thoroughly.
Great. Let's get this research started.
Okay, let's go in Hangsan.
Go, go, go.
So we gather up in front of the Inangsan with other groups. So this is a picture of us at the beginning of the Inangsan. And so we hike like this. We gather up in front of the map of Inangsan and we choose where to go. So we just keep hike, climb the mountain, keep climbing, and we see some kind of a rock that, well, it well preserved, really well preserved joint. So yeah, we collect the data like this, and we'll find some huge rock with a massive joint. So we choose this sample too. And also we can see some beautiful scenery, like, you know, view of Seoul. This is halfway before the top of the mountain. Well, we have some few accidents, but we managed by ourselves. And finally, we gather up and we finally climb the top of the mountain. And this is our group picture at the top of the Inangsan. So before we all groups said, we finally finished our travel to Inangsan, and we will tell you about our joint orientation analysis at Inangsan. We are group 2, Park Hyun-se, Park Seon, Kim Yu-seung. Our contents of our presentation is like this. We have experimental purpose, theoretical element, experimental method, selection of location, the result, and finally conclusion. First of all, experimental purpose. This experimental purpose is to determine the dominant average orientation of a joint set. And by this, we identify the most pre-relevant direction within a rock mass, which is critical for geological and engineering applications. Next is theoretical element. First, we got strike, the direction of the line where the inclined joint plane sects the horizontal plane. Next is dip, the angle between the joint plane and the horizontal plane, measure upward from the horizontal. Next, dip direction. The azimuthal direction in which the dip is oriented with the projected onto the horizontal plane. And lastly, direction cosines. These are the components of a normal vector to the joint plane calculated using the angle strike and dip. Well, next is experimental method. Firstly, we calculate the normal vector. Each joint plane's normal vector is calculated using the strike and dip values, and the component of the normal vector represent the spatial organization, the joint in 3D space. Next, by this, we summing the normal vector. The normal vector of all joints are summed to compute the resultant vector. The magnitude of this resultant vector is calculated to measure the consistency of joint orientations. And lastly, dispersion of joint orientation. The dispersion of joint orientation is quantified using the equation at the below. Next is the reason why choose the Inang Mountain. First is abundance of exposed rock, so it's easy to collect sample. Next, the development of various joints. Also, it makes us easy to figure out the result. Next, geological significance of joint county. And next is accessibility and safety. It is very easy to climb, not so high mountain, and it is very easy to go from Seoul. And lastly, rock engineering and environmental applications. So this is a picture of our climb route in Inangsan. This is left, there's a beautiful scenery of Inangsan. And on the right, we choose this. When you see the map, we climb the mountain as a red route.
Hi, I'm Park Xiang. I'll now present the results. On the left, you can see the image showing that the route of our hiking project. And on the right, you can see the image displaying the 10 joint sets we investigated. This table summarizes its joint set, including their dip and strike. As mentioned earlier, we also calculated the components of each normal vector using the direction cosine method. The dispersion value Kf was determined to be 4.74. A value of 4.74 indicates that we achieved a certain level of pattern recognition. Therefore, this project can be considered relatively successful. Looking at the stereo-net diagram, you can see this more clearly. The dots are clustered together in a specific region, confirming our findings.
Okay, hi, I'm Yusung. Yeah, now let's conclude our discussion on this experiment, which focused on studying the cracks in rock joints. This experiment, commonly referred to as joint orientation analysis, plays a vital role in geology and rock mechanism. The primary objective is to understand the spatial distribution of joints by determining the dominant average orientation and evaluating how consistent those orientations are across the sample. The result of this analysis hold immense significance. First, they offer geological insights, helping us better understand the nature, formation, and distribution of rock joints. Second, the data is highly applicable in rock mechanics and engineering, where it supports the design of stable structures like tunnels and slopes in geotechnical projects. Lastly, this study provides foundational data for both theoretical research and practical application in geotechnical and structural engineering. To sum up, the experiment doesn't just quantify joint orientation, but also provides crucial insights that bridge geology and engineering, ensuring safety and efficiency in construction and research. Thank you for viewing our video. Thank you.
Thank you for listening our project. Thank
you.
you.